You're welcome.
We'll try not to complete.
It just seems dumb. It just seems like I look up like just one single like waveguard section of it. And then for the second one, I got my exact is like wavelets. I don't know I might walk over there. I think I need to market.
Yeah, it's right over there.
I'll meet you in the boat.
Yeah, you know what?
I'm not good. I'm ready. Now I'm excited. Like hiking. I would you redo it.
What'd you get?
Zinc air. What is it? Zinc air.
My average was 2.6 something. My average was like 2.7 something. Wow. I did like 2.7.
He's gonna yell at us. At least the child is
I wrote 3 pages of
I still didn't show him. I said, I'm gonna write it out. And I'm not
He's just really way too fast. Yeah, I'm going straight.
Is the time, is that like your position or
I probably was lucky and chose a random one for my like temperature for my second time. I was just like, you know, 150 sounds about right. I was like, why not?
like your own figure what temperature range. Like, I'm gonna choose my this temperature for some reason. Straight to the right pressure.
Crazy.
lucky for this? Okay, I have zero idea.
It's due a week now, so
Actually,
this last
Then I have to process it out the same day.
wait, is it like the
And then we will work the same day.
what do you write? Like a mission.
I'm just
oh, I did. For the memory.
experiment, and it's going to be punished severely.
It's like I was just committees actually.
You're able to answer.
I was really thinking about having the disabled thing. That's not a good but it's going Oh, he never I refuse.
They're not new.
No. And then he asked like,
So you're here at Eats. I just sound just like
Hello, required. Is anyone taking a video? You are? Okay. Okay. Hey, I see this assignment, very nice and written, beautiful. The first key question, refrigerant, safe, environmental friendly. That was a problem you guys didn't pay attention when you did it last time, right? And got everything correct. And here it is, bubble point, a reflux drum, top temperature, bottom temperature, relative volatility. Everything is correct. Are you feeling better after you've done this? I'm not trying to intimidate you. Just want you to learn this thing. Like Google to get answer, that's not in your textbook, right? So, this is a good lesson. You're a senior now. A lot of problems require you to do research, okay? Google it. All right, let's continue. Page 38. What do you need to include in the project report in terms of stream information? Essential information. If you have C component, you need to specify C plus 2 variable. What are those? temperature, pressure. TP. Now the next one you have the option. Here is total flow rate, stream composition, such as FZI, FI, component flow rate. So C plus 2, what are the C variable? C component flow rate. So for any stream, you must specify C plus 2 variable. If you give me total flow rate, stream composition, multiplying the 2, essentially is component flow rate, right? Yeah.
We can't see the one side.
Oh, okay, sorry. Now, you want to say in the table, look at the bottom table, stream 1, 2, 3. There's the temperature here, pressure here, right? And if you put component carbon 2, carbon 3, you put more flow. C, right? Those are the minima or essential information you must put into your project report. Optional information, optional, such as density, viscosity, when you learn Aspen simulation, you can get a property, a physical property value on the stream report. Now, what are those? There is a standard notation. If you have a stream going this way, stream, you want to indicate temperature, you put 100 C. That rectangular. You want to put pressure, okay, stream number. So you go to the next page. So you want to add information on the stream. Aspen simulation will do it for you if you ask it to do it. So 100 degrees C, you see here, pressure 15 psi, different simple, okay? And bottom of page 38 gives you temperature and pressure, component flow rate, minimum information. That's what you need, okay? Now, The next thing on page 40 is you do not need this, probably not in your minor report, not even in your final report, final project report. What does 9 schedule mean? If you have a stream, 9 number flow medium, what's inside, temperature, pressure, plus physical property like density, specific gravity, flow rate, non-origin termination. This stream from where to where. And this is similar, simplified. Line schedule from where to where. Okay? We don't use that in our design class. Now, later on, when you write your final design report, you have different type of equipment like pump, exchanger, tank, vessel, reactor, and so on. I will give you the standard format to write down what we call equipment table. Okay, here's some example. Pump summary, different type of pump. Vessel and tank or exchanger. In the next few days, I'm going to give you some example in case you know the preliminary dimension capacity of your vessel, tank. How do you set up a table for equipment table? So, you will have stream table, equipment list by type. I'm sure you have a couple of exchanger in your project, vessel, reactor, and so on. How do you write down the preliminary dimension before you actually slide them on Aspen? I will send this to you. Now, the next thing is little trouble. What type of symbol you use to draw your flow sheet? If you install your Aspen by next Wednesday earlier, it might benefit you. I teach you how to draw the flow sheet on Aspen, use their symbol, even before your training, okay? You want to do that or not? If not, you have to find this wonderful symbol beginning page 43 to draw your equipment like distillation column, reactor, and so on. Okay? Try to install your Aspen by Wednesday. If enough of you done it, I can demonstrate, teach you how to draw flow sheet. Half hour. okay, using Aspen's equipment symbol. Now, I have collected how many pages, my goodness, from different sources. Process vessel, what is the difference when you draw a distillation column using tray, packing? The general symbol for packing is, you notice, that is for packing. For tray, you can just draw the tray. Now, you look at the pump. Depending on the direction, you draw a pump, right? You want to go this way, you want to pump up to a destination. You can do that. Or you can go like that. You notice this flexibility when you vary the destination. Now, down here, cooler means cooling. You draw temperature going downward, heater going up, exchanger, you have a process stream. So here is a cooling. You can go down or you can go up to you. The main thing is coolant must be drawn downward. Steam going upward. All right, look at page 44. This is what I say to you before. How do you tap a stream? Flow rate, pressure, temperature, component flow rate, watch here, flow meter. You go to your old lab, did you play with a rotometer? What's the flow direction? Up or down? Up. Tell me, if Wahoo engineer do like that, that's wrong. Okay? The flow direction must be consistent with actual direction. Now, you want to draw the pressure controller, temperature controller. The other thing, all right, page 45. The following symbol came from Chemical Engineering magazine. If you have a mixer or agitator, you better have this agitation included, okay? There are other notation here. I'm not going to go through it. Page 47. In a good old textbook, Peter Timmerhouse, their textbook came out, they took over the market, Frank Milburn textbook stopped. They replaced it. Right now, the latest edition, 2003, all the other are in heaven. Nobody is taking care of it. McGrady no longer print the book, unfortunately. All right, go to page 48. If you have a column, so you have a column, whatever you call it C1 or B1, what will be the name? What are the standard? If you follow a conventional Dow Chemical, this gentleman came from Dow Chemical. He liked to use B for distillation column for vessel. Okay? You notice here? Now, up here there's the textbook. What is the notation for column? S, separated. So, you really need to be consistent to choose this. For example, heat exchanger, H. Sometimes you use E for exchanger. E1, E2, so on. I'm sure there are pump in your flow sheet, reactor in your flow sheet, tank. Compressor C. So, choose one of the list. On page 49, this is easy stuff, right? How do you number different equipment? First separator, second separator. If you have two identical separator, S3AB, parallel. C, compressor number 2. C is compressor, S separator, right? Now, down here, you have 3 compressor, ABC. 1 comma spare unit, S. Down the bottom here, if you have a large flow sheet, so you have a reactor section, separation section, different section. So, C is compressor, I'll call this 101, 102. If I have a pump, P101, P201, this section is 200 series. This section is 100 series. Okay? That is here. If you have exchanger E101, E202, exchanger in different sections. In a large flow sheet. Easy? All right, next page. Now, some recommendation to draw a simple, effective flow sheet. You see on the top of the station column, you draw a cooling condenser here. That's a cooling condenser. That is a typical one we include in your project report. How about other more complicated? It really depends on your purpose. Why do you need to show all the detail? There are many types of valves. In the flow sheet, you typically use a simple notation valve. Okay? Now keep going. Page 52. When you draw the compressor or pump, depending on the inlet stream, outlet stream, what direction, you can turn this properly. I told you this is wrong. This is better. Rotameter. Flow direction is going up. Aha! I did tell you this. This is oversimplified. A mixer without agitation, that's no good. So, this is a recommendation. When you draw the flow sheet, avoid bends and crossover. Go to page 56. Let's look at this big flow sheet. First thing, this pump is sending over a stream to the top. Location of different equipment items should reflect the actual elevation. Okay? This is the wrong place. Now, you look at this, top string come out. Okay, here, cooling water. First thing is, avoid crossover bends and cross over. That means you need to determine where is the best way to draw this part. This product probably come out from very top, right? Now near the bottom, this elevation is questionable. Product pump. Because you put that such a low location. You created 3 lousy crossover. You see that? That's not good, right? The other thing is, this pump, you can move this column to the left a little bit. You could have sent this from this side. The way it is, you come in, eventually come out, right? And this goes to the middle, there's a crossover. Now, this steam, the way it is, this steam is actually for the reporter. You want to watch here? He even sent that across the column to this reporter. Steam heating for reporter. Steam is near the bottom of the column. It's at the very top. Crossover, this is called bend. And crossover, bend. This is crazy, right? Why don't you just simply send the steam here? It's not so easy, right? You understand? What's wrong with this flow sheet? The crazy thing is, I do not like Mr. Ludwig. He liked textbook, third edition, still do not get it. I have the first edition, second edition, third edition. Each time I spend money buying this book to learn it, I look at that page and say, wow. We can continue to joke about this flow sheet. The key point in the thing is elevation of different components. Avoid, bend, and crossover. Okay? In previous year, I will ask the class to give me a better one. When we still have time after your minor project, you draw this, make it better. I have a good one, I could not find that transparency anymore. My office is a mess. Okay, do you get it when you draw your flow sheet? Avoid bend, crossover, proper elevation, location. Okay? Any question? All right. Page 27. Project hard copy. Monday, I think it's 29, is that right? Class time. Due. Is that 29? Okay. Now, this happened to be a weekend. Half of you are doing training. The other half, you can enjoy Saturdays. You better work on Sunday afternoon or something. Monday, deliver a good one. For those who do a training, sorry, you need to do more work. But you recover the following weekend, all right? Now, production consumption table, fairly straightforward. Separation test. Remember in your class notes, go to page 9. When you choose your separation method, page 9, you need to pay attention to the phase condition of feed and product. What physical property? Here, we have been working with normal boiling point. You need that. At least you need to consider density or specific gravity and solubility in water. At least you want to find other physical property to choose the separation method. Go ahead, convince us. At least you need to consider those. And the answer for your separation method are all in page 9 to 13. All the separation method are in here. Okay? And you need to consider both vapor, liquid, those equivalent base, or rate base, both. Your process include both. All right, it's all in here. Now, my suggestion to you is, once you think about, hey, for example, go to page 13. You say, I have a feed phase, product phase. Can I use density difference, size difference? You notice there are two types of centrifuge. Google research. Whatever you do not know, Google it, find out a similar example. I do not know all of this method. What do I know? Crystallization. I did my master's thesis on it. Adsorption. I wrote a book on it. Okay? So, we're not master at everything. You ask me, can I use this? Please teach me. I do not know the answer. Okay? I do not know everything in here. You justify and teach me. Okay? That's the nature of senior design. All right. Now, back to page 27. Task assignment integration. Page 17. You might need to set up a table of task assignment, or you do not want this table, you want it easier. Probably, what is my yeah, let me see. There is a page. Let me find it. What is it? Not here. Where is my copy? You show me your copy. Put your iPad up. I might not have that page. Not this example. Okay. Where is that page? Not here. Oh yeah, page 8. I think in your solution, page 8, you want to do your task assignment integration, right? You have 3 reactors. You put down pressure change, temperature change, phase change, and then you change that to equipment. This is easier. Do you get it? Page 8. So now you have 3 reactors. Your task assignment, if you do not use that crazy table, this is the best approach. Okay, thank you. Now, back to page 27. What time do we have? Okay, I teach that after the break.
It's double spaced, not color.